Hello everybody, welcome into another lesson. So today we're going to talk about other methods of proving triangles congruent. So far we've learned side angle side, we've learned side side side, angle side angle. Those are some methods that we've learned. Now we're going to talk about what else? We've talked about the isosceles triangle theorem. Today we have some more. Here we have the angle-angle-side theorem. This theorem states that if two angles and a non-included side of one triangle are congruent to the same parts of another triangle, then the two triangles are congruent. So here you have triangles ABC and DEF. We see that angle B is congruent to angle E, angle C is congruent to angle F, and then side AC is congruent to side DF. So you have two angles and the non-included side on each triangle. By that theorem, we can say that triangle ABC is congruent to triangle DEF by the angle-angle-side theorem. And this, of course, works with all triangles. Everything we've learned so far works with all triangles. So I'll give you a minute in case you're trying to write notes on this or whatever. I'm going to give you just a minute here to look at this and understand it. All right. Now, we're about to learn 4 more methods, but the next 4 apply strictly to right triangles. They only work for right triangles. The methods we've learned so far work for all triangles, including right triangles, but the next 4 are strictly for right triangles. We have the next theorem called the hypotenuse-leg theorem, the HL theorem. Actually, before I get into that, let's get into a right triangle. Everyone by now should know what a right triangle is, I would hope. A right triangle simply has a right angle in it. Well, the side opposite the right angle is called the hypotenuse. That's always the side opposite the right angle is going to be the hypotenuse. And then the other 2 sides are called your legs. So here's a leg, and here's a leg. And then, of course, the other 2 angles here are going to be acute angles in a right triangle. So those are the parts of a right triangle. Now let's get into the theorems. The HL theorem, the hypotenuse-leg theorem. Let's see what that states. The hypotenuse-leg theorem states if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the 2 triangles are congruent. So let's go ahead. I'm going to draw a couple right triangles here. Ah, that was terrible. Hold on a second. Let's draw a couple right triangles side by side here. All right. Well, it'd probably help if I label the points, wouldn't it? That way we have something to compare. All right. And then we got our congruency markers. Okay. So the hypotenuse leg theorem, the HL theorem, states that if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. So here I have triangles ABC and DEF. We see they're both right triangles. We see that the leg BC is congruent to leg EF of these two triangles, and then both hypotenuses AC and DF are congruent. Well, by the HL theorem, that allows me to conclude that triangle ABC is congruent to triangle DEF by the HL theorem. So that's what the hypotenuse leg theorem states. And it actually is kind of a nice shortcut, honestly. All right. I'm going to change this a little bit because from this theorem is derived three other theorems that are very similar. So let's see here. Let me get this triangle redrawn here. All right. So next we have here, let's just make the congruency markers here first. Okay, next we have what's called the HA theorem, the hypotenuse acute angle theorem. If the hypotenuse and an acute angle of one right triangle are congruent to the hypotenuse and an acute angle of another right triangle, then the two triangles are congruent. So once again, we have triangles ABC and DEF. They're both right triangles. We see that angles A and D are congruent, and then hypotenuse AC is congruent to hypotenuse DF. So by the HA theorem, the hypotenuse acute angle theorem, we can conclude that triangle ABC is congruent to triangle DEF by the HA theorem. So very similar, only we don't have a leg this time. We have an acute angle in the hypotenuse. So that's another tool you can use. And now I'm going to keep these two triangles still because we're about to do two more theorems that are really going to help us. Alright, next one will be the LL theorem, the leg-leg theorem. Alright, so here, let me draw the triangles back in. Let me place the congruency markers here. Alright, so the LL theorem, the leg-leg theorem, states that if two legs of one right triangle are congruent to two legs of another right triangle, then the two triangles are congruent. So once again, we have triangles ABC and triangles DEF. We have leg BC congruent to leg EF. We have leg AB congruent to leg DE. By the LL theorem, we can say that triangle ABC is congruent to triangle DEF. That's going to be by the LL theorem. All right. Then I have one more new theorem here. This one's going to be the LA theorem. Alright, let's draw these in, then I'll explain this theorem here in a second. Alright, so last but not least is the LA theorem, the leg acute angle theorem. This theorem states that if a leg and an acute angle of one right triangle are congruent to a leg and an acute angle of another right triangle, then the two triangles are congruent. So once again, we have, whoops, why did I erase those points? I did not mean to do that. There we go. So we have triangles ABC and then DEF. Here we see that leg BC is congruent to leg EF, and then angle C is congruent to angle F. So by the LA theorem, we can say that triangle ABC is congruent to triangle DEF by the LA theorem, the leg acute angle theorem. So these are all some really good tools for dealing with right triangles. And again, we're going to go over a brief recap of what we've learned so far. So here is a summary of what we've learned in this course with proving triangles congruent. So let's see. All triangles. So for all triangles, we've learned so far side, side, side. We've learned side, angle, side. We've learned angle, side, angle. And then today we've just learned angle, angle, side. All of those methods will work for all triangles. Now, for right triangles only, we have not only those four methods, we have hypotenuse leg, hypotenuse acute angle, we have leg leg, and leg acute angle. So these are all the methods we've learned so far for proving triangles congruent. So once again, the first four work whether it's a right triangle, obtuse, an acute triangle, no matter what. All of these here, the side, side, side method, side, angle, side method, angle, side, angle method, and the angle, angle, side method work for proving all triangles congruent. The bottom four here only work for right triangles. The hypotenuse leg, the hypotenuse acute angle method, the leg leg method, and the leg acute angle method. So now you have a bunch of methods in your arsenal for proving triangles congruent. Alright, let's do some exercises here. We're going to do some real quick. So, let's see. Let me draw a couple triangles here. Alright, so we have a couple of right triangles here. You can see they're connected. Now, we need to determine A, if they're congruent, and B, by what method are they congruent? Well, we know they're right triangles. We can clearly see the hypotenuse of each one is congruent. Are there any other ways we can tell? Well, look at these two angles here. They're vertical angles, right? We know vertical angles are congruent. So now what we have here is we have the hypotenuse and an acute angle congruent. So these are congruent by hypotenuse acute angle. So yes, these are actually congruent by the hypotenuse angle theorem, hypotenuse acute angle theorem we can use. So that was good to use. What's next? Alright, we got a nice upside down triangle in this one. That's going to be split into two. What else do they give us? They give us here, this is a right angle, and then these two sides are congruent to each other. Okay. Let's look at this here. So, we know that this is really one triangle split into two, right? Both hypotenuses are congruent. Well, we have a right angle here, so obviously this side's going to have to be a right angle too to form the whole line, so we can deduce that this side's also a right triangle. Now, I think it's plain to see that both triangles share this angle, they share this side here, they share this leg. So we can actually prove these two triangles congruent by the hypotenuse leg theorem. These two triangles are congruent by hypotenuse leg because the hypotenuses are congruent, and then you have both triangles share the same leg. So the hypotenuse leg theorem works. There's another way we could have proven these congruent. If you look at the whole triangle, both of these sides are congruent, meaning you can use the isosceles triangle theorem to prove these opposite angles congruent. You could have actually used, there's a couple other methods. You could have used hypotenuse acute angle theorem. So the HA theorem is also a way to prove it. And then you have the leg acute angle. You even could have used the LA theorem, the leg acute angle theorem. So there's actually three ways we can prove these two triangles congruent. Take your pick. You only need to use one of them, but there were actually three ways we could have proven it. Okay, what's next? Alright, there's two triangles touching. Let's see what they give us. They give us this angle, they give us this angle, and they give us that these two sides are congruent. So far, all we've been given is that we have two congruent angles and two congruent sides. So far, nothing stands out to prove these two triangles congruent. Well, aren't these two vertical angles? We know the vertical angles are congruent, right? So now, since we have another pair of congruent angles, we can use angle side angle for each one. So these two triangles are congruent by the angle side angle theorem. So that wasn't too bad. Okay, what do we got next? Another two right triangles. Sorry about that screech. Nails on the chalkboard, right? Okay. Let's see what we got here. Yes, these are both right triangles. What else have we established with this one? These angles are congruent. Now, let's see here. Can we deduce a congruence? We know nothing about the sides in this case. They don't give us anything about the sides. All we know for sure is that all the angles are congruent, but there's no method for just only angles proving congruent. Later on in the course, we'll get to what's called similar triangles. We could, if we were on that part, we could prove the triangles were similar, but we couldn't prove them congruent. So In this case, no congruence can be determined because we know nothing about the sides, we only know about angles. So no congruence can be determined in this particular case. Okay, what's next? Another triangle here. Let's see what they give us. Alright, let's take a look at these two triangles. It looks like we got a whole lot of nothing. And of course, this is one triangle split into two. They obviously share this side. But that would give us angle side side or side side angle, which we don't have a theorem or postulate for that. However, let's consider the whole triangle, not split into two, but as one triangle. We have both of these opposite angles congruent, right? We can apply the isosceles triangle theorem to use the fact that both of the opposite sides are congruent to each other. Now that we can determine that by the isosceles triangle theorem, you have a side angle and a side of each triangle congruent. So these two triangles are actually congruent by the side angle side. It's actually a postulate, not a theorem. I gotta correct that. There we go. By the side angle side postulate, both of these triangles are congruent. Okay. I could draw that a little bit better. All right, got some triangles here. These are for sure right angles. We got that much. All right, so here's what they give us for these two right triangles. It looks like so far we know the right triangles. We know that one pair of legs is congruent in each triangle. But if we look at this here, don't both of these right triangles share the same hypotenuse? They do, in fact. So by the hypotenuse leg theorem, we can actually conclude that both of these triangles are congruent. Since they share the same hypotenuse, that would make them congruent. And by the hypotenuse leg theorem, both of these triangles are actually congruent. All right, what do we got here? right triangle, right triangle. As a matter of fact, that's really all they give us. We just know these are two right triangles. Well, that's great. Now, how about this? All we know is that the hypotenuses are congruent since they share the same hypotenuse. We know nothing about the other sides. We know nothing about the other angles. All we know is they share the same hypotenuse. So, in other words, we can't deduce a congruence. So, no congruence can be determined. So in this case, only because we know the hypotenuse is congruent, and that's all we know, is that no congruence can be determined. All right, one more of this exercise, and I have 3 proofs today. I do have 3 proofs. Not my best drawing, but anyway, we have 2 right triangles here. What else are we given? We're given that these 2 angles are congruent. We're given that these 2 legs are congruent. Okay. This one's kind of loaded. So, I could tell you right now these 2 triangles are congruent, and there's a couple ways to prove it. So, we notice they're both right triangles. We have each a leg and an acute angle congruent. So for sure we have the leg acute angle theorem we can prove that they're congruent by. What else? They share the same hypotenuse, therefore making both hypotenuses congruent, and they have congruent legs, so they're also congruent by the HL theorem, the hypotenuse leg theorem. And then again, they share the same hypotenuse, and then we have 2 congruent acute angles, so we can also say the HA theorem for this one, the hypotenuse acute angle theorem. So take your pick with any of those 3. Those are 3 ways to prove that these 2 triangles are congruent. All right. Now I do have a few proofs. Okay, here, let's see. W, X, Y, Z. What else do we have here? We got for sure that these are both right triangles. Alright, so what are we going to prove today? What are we given? So, in this particular case, we're given that angles W and angle Y, angle Y are right angles, we're also given another piece of information. We're also given that WX is congruent to WX is congruent to YX. I was reading the wrong line for a second. So what we have to prove here is that WZ is congruent to YZ. Okay. So we got two right triangles side by side. We're given that angles W and Y are right angles, and we're also given that WX is congruent to YX. In fact, why don't I go ahead and mark that? That's going to make our lives a lot easier when we do that in the diagram here. Okay. What we have to prove is that WZ is congruent to YZ. Okay, this actually won't be that bad. Let's go ahead and set up our columns. So, statements and reasons. Okay, so statement 1 is that angle W and angle Y are right angles. That, of course, the reason for that is it was given to us. Alright. Now, by that definition, we can determine that triangles WXZ and triangle YXZ are right triangles. That, of course, will be by the definition of a right triangle. Not or, of. Okay, so far we used the given information that angles W and Y are right angles. That was given, which would then mean that triangles WXZ and YXZ are right angles. They're right triangles, excuse me. That's by definition of a right triangle. Okay. Now we can use the next piece of given information that WX is congruent to YX. That, of course, reason 3 is it was given to us. Alright, well, let's look at this diagram here. Don't they appear to share the same hypotenuse? XZ is the hypotenuse of both of these triangles. So obviously, that's going to make XZ congruent to XZ by the reflexive property. So XZ is congruent to XZ for reason 4. That's just the reflexive property. Alright, where do we go from here? In each triangle, since they're right triangles, we have a leg and the hypotenuse congruent. So now we can say that triangle WXZ is congruent to triangle YXZ. That's going to be by the hypotenuse leg theorem, the HL theorem. Which now, last but not least, we can prove that WZ is congruent to YZ by CPCTC. Okay, so let's go through this proof again here. So we have our two right triangles, WXZ and YXZ here side by side. We're given that angles W and Y are right angles. So that was our first statement. That, of course, was given. By that definition, that means that triangles WXZ and YXZ are right triangles. That's, of course, by the definition of a right triangle. Then we use the fact that WX is congruent to YX. That was given to us. And then XZ is obviously congruent to XZ. That's by the reflexive property. And now, since each triangle had a leg in the hypotenuse congruent, we can conclude that triangles WXZ and YXZ are congruent to each other by the hypotenuse leg theorem. Which then means we can finally prove that WZ is congruent to YZ by corresponding parts of congruent triangles are congruent. So that actually wasn't too terrible. It was 6 steps, but if you know where to go from each step, it's really not that bad. I got 2 more proofs, then we're done with the lesson for the day. Okay, what's next here? Angles 1 and 2 are right here. Okay. So we have 2 more triangles. We have triangles KLA, and then we have KJA side by side. Let's see what we're given this time. So what we've been given is that KL is perpendicular to LA, what else have we been given? We've also been given that KJ is perpendicular to JA. We've also been given something else. We've been given that ray AK bisects angle LAJ. What we have to prove in this case is that LK is congruent to JK. Alright, so for this proof, we're given that KL is perpendicular to LA. Well, let's start there. We can mark that in our diagram, right? If these are perpendicular, that means they form right angles. So that's going to make your life easier. We're also given that KJ is perpendicular to JA, forming another right angle. And then we're given that AK bisects LAJ. Well, if they bisect, that means you got 2 congruent angles. So that's good to mark in your diagram. Okay. Let's go from here with the proof. Well, let's set this up here. Alright, so let's begin with our first statement. I would start out with the first two pieces, that KL is perpendicular to LA, and then KJ is perpendicular to JA. Those, of course, have been given to you. Alright, so now that they're perpendicular, that's going to mean that angles L and angle J are right angles. That's going to be by the definition of perpendicular lines. So now we've established right angles. From there, we can establish that triangle KLA and triangle KJA are right triangles. That, of course, will be by the definition of right triangles. So far we've used the first two pieces of given information about the perpendicular lines, which means we can conclude that angles L and J are right angles by the definition of perpendicular lines, which from there we can conclude that triangle KLA and triangle KJA are right triangles by the definition of right triangles. Okay, so from here we have ray AK bisects angle LAJ That, of course, was given to us. Which from there we can conclude that angle 1 is congruent to angle 2 by the definition of angle bisector. Okay, so now what else can we conclude? Well, both right triangles share the same hypotenuse of Ka, so obviously Ka is congruent to Ka by the reflexive property. This would be the reflexive property for step 6. So now with these two right triangles, we have an acute angle and a hypotenuse that are congruent, which means next is to say that triangle KLA is congruent to triangle KJA by the hypotenuse acute angle method. So by the HA theorem, we can conclude that the two triangles are congruent. So now all that's left to do is prove that LK is congruent to JK by CPCTC. So step 8, LK is congruent to JK by CPCTC. That's a fun one. All right, let's go through this proof here. That was an 8-step proof, but sometimes you'll have that. So we have two triangles here, KLA, KJA. What they give us is that KL is perpendicular to LA, and that KJ is perpendicular to JA. We made that our first statement of the proof. Those were given to us. And if those lines are perpendicular, that means that angles L and J are right angles by the definition of perpendicular lines. And then we can conclude that triangles KLA and KJA are right triangles by the definition of right triangles. Next, we use the last piece of given information that ray AK bisects angle LAJ that was given, which would lead us to angle 1 is congruent to angle 2 by the definition of angle bisector. Then, of course, KA is congruent to KA by the reflexive property, which now we can conclude that triangles KLA and triangle KJA are congruent to each other by the HA theorem, the hypotenuse acute angle theorem. And finally, we could conclude that LK is congruent to JK by CPCTC. Corresponding parts of congruent triangles are congruent. So that one was a little more loaded. Unfortunately, that's just how it goes in this business sometimes. I will say this whole course is not going to be proofs. I'm on, what, chapter 4? We get through chapter 6, because there's 14 chapters to go, well, really 13. There's 13 chapters to go through. Once we get past chapter 6, the proofs cease for the rest of the course. So we don't have much more to go with proofs, but there will be some. All right, one last proof and we're done. All right. Not exactly drawn to scale, but whoa. Yeah, definitely not drawn to scale. Here's how I should do it. There we go. That's more like it. That's what I was trying to achieve. H, E, F, G. Okay. So once again, we have our two triangles side by side which appear to form a parallelogram. So let's see what we're given here this time. We are given that EF is perpendicular to EG. What else are we given? We're given that HG is perpendicular to EG. We're given one more piece of information. We're even given that EH is congruent to GF. So what are we going to prove this time? What are we here to prove? Well, the proof is going to be that angle H is congruent to angle F. So let's start with a couple pieces of information here in our diagram. EF is perpendicular to EG, Well, that means that you have a right triangle here. You have a right angle. We're also given that HG is perpendicular to EG, so that's another right angle. Okay. And then we're even given that EH is congruent to GF. Alright, so let's go ahead from here and let's start our proof. So let's make our columns. Make it nice and big this time. Okay, let's start with a couple pieces of information here. Let's take the first two, we'll omit the third for our first part. So the first statement's going to be that EF is perpendicular to EG, as well as that HG is perpendicular to EG. That, of course, was given to us. Well, if we have perpendicular lines, that means that angles HGE and FEG are right angles. That's going to be by the definition of perpendicular lines. Which then, if we've concluded right angles, the next step is to conclude that triangles HEG and triangle FEG, God bless America, or FGE I should say, are right triangles. That would be by the fact of definition of right triangle. So now we've established right triangles. Step 4 is that EH is congruent to GF, that was given to us. What else? Then obviously both of these triangles share the same leg. EG is going to be congruent to EG by the reflexive property. Okay. So in these right triangles, obviously the hypotenuses are congruent, and then we have a leg congruent. So we can conclude now that triangle HEG is congruent to triangle FGE by the hypotenuse leg theorem, by the HL theorem. So now we've concluded congruent triangles. All that's left to conclude is that angle H is congruent to angle F by CP/CTC. That'll be step 7, CP/CTC. Alright, so let's go through this proof real quick. So we have two right triangles side by side, triangles HEG and then FGE. What they tell us here is that EF is perpendicular to EG and HG is perpendicular to EG. We use that for statement 1 for our given information. If that's the case, then that means angles HGE and FEG are right angles by the definition of perpendicular lines. Which now, since both of these triangles have a right angle, that means triangles HEG and FGE are right triangles by the definition of right triangles. Then we use the last piece of given information for step 4, that EH is congruent to GF, that was given. And then obviously EG is congruent to EG by the reflexive property, which then leads us to conclude that triangle HEG is congruent to triangle FGE by the hypotenuse-leg theorem. And then last but not least, angle H is congruent to angle F by CP/CTC. Corresponding parts of congruent triangles are congruent. So that's it for this lesson. Next lesson, we're going to do a few proofs using more than one pair of congruent triangles. So I hope everyone has a good day. Take care.